Hi guys, welcome to Electrical Project channel. Today I'll show you how to build a simple spectrum analyzer that can analyze light including infrared and ultraviolet light. The two key components of this device are web camera and empty DVD disc. But also we'll need some kind of housing for the analyzer. The material of the housing should not be transparent, and of course it will be better if the material is black. I'm going to use wooden planks, painted black. But before building the analyzer, I'm going to remove the infrared filter from this web camera. It's not necessary to remove the filter, but if you remove the filter, you will be able to analyze infrared light also. And I really want to make this analyzer as useful as I can, so I'm going to remove the filter. This piece of glass on top is infrared filter, so let's remove it. Now the camera is ready to see infrared, so let's assemble it. Now let's build the housing. The main idea here is to build a box with a slit for the light on the one side. So let's do it. Now when the box is half completed, let's install the camera. I'm using a screw to fix the camera to the housing. Remember, the camera should be installed on a 30-degree angle. Now when the camera installed, we can glue a piece of DVD disc to the lens. Let's unscrew the lens and prepare DVD disc. But first let me explain why do we need DVD disc at all. Well, DVD disc works like a diffraction gratings. In other words, it splits light into a rainbow, and the web camera will see the rainbow and software will analyze it. Well, enough talk. Let's break the disc already. Nice. This piece of DVD disc looks good enough, so let's glue it using some hot melt adhesive. Now let's install this lens with a piece of DVD disc, and this device almost ready. Now after adding additional wooden planks and beaming light through the slit, you should see a horizontal line on the spectrum analyzer software. If it's not the horizontal line, you should rotate the lens and make the line horizontal. Adjusting is very individual, just experiment. Here's how my completed analyzer looks like. Now we need to calibrate this analyzer. I will use a fluorescent lamp. With this cardboard box, I regulate the amount of light that spectrum analyzer gets through the slit. And here is the light source. It is just a regular fluorescent lamp. Let's have a look at the spectrum. As you can see, the fluorescent lamp produces not continuous spectrum, and the spectrum has a lot of peaks. Not all of these peaks are stable. But these two peaks are stable and they don't move. They are 436 and 546 nanometers. So let's use them for the calibration. To do the calibration, you need to click Tools, Trim Points, choose fluorescent 436 and 546 nanometers. Now we need to align these two peaks to 436 and 546 nanometers respectively. Now click on Trim Scale, and after that the calibration is finished. Now I'll show you how different light sources look like on the spectrum. We already saw the spectrum of a regular fluorescent lamp, but now let's try something more interesting. This is Wood's lamp, sometimes also called black light. It produces ultraviolet light. Let's have a look at the spectrum. As you can see, it produces a little bit of blue, some violet, and also it produces ultraviolet light that is not visible for our eyes. Now let's test a regular incandescent light bulb, and I'll show you why this bulb is not energy efficient. Just have a look how much energy is wasted on the infrared light. We cannot see infrared, but most of the light is infrared light, so basically this light bulb mostly produces heat instead of visible light. And maybe it's okay in winter, but it's definitely not good in summer. Now let me show you the spectrum of these white LEDs. The light from LED is much more better than the light from the fluorescent lamp, because there is no such high peaks. The spectrum is more even. And now I'll show you how RGB color mixing works. To demonstrate that, I'll use RGB lighting that I have in my room. First, let's choose pink color. As you can see on the spectrum, it's actually not pink. It is blue and red turned on together. Moreover, there is no pink color even on the rainbow spectrum, which means it's not a real color at all. Your brain just makes this color up when your eyes see blue and red. And when I choose white color, it is just red, green and blue turned on 100%. Now let me show you how automatic color mixing works. And the last thing that I want to show is the spectrum of this remote control. Of course, it's obvious that it is infrared remote control, but let's have a look anyway. As you can see, it emits light 930 nanometers. And as you can see, it is beyond the visible spectrum that human eyes can see. To detect this light, it is necessary to remove the infrared filter from the web camera. And that is all for today. Like this video if it was interesting, and thanks for watching.